All right. That is weird. Okay. All right. Good evening and thank you for joining me. We are currently looking at Tropical Storm Bertha. So let's look at satellite imagery. We have a hurricane in the Pacific, Hurricane Fausto, which is currently moving through some pretty warm waters in the Pacific. It's having a hard time getting its act together, and it will be moving into cooler waters shortly, so I don't expect it to get too strong. However, um, Fausto did, I believe, become pretty intense, but it is forecast to become a hurricane for at least the next several days, so at least Sunday. And we are talking about El Nino conditions, which could help the system maintain intensity and also strengthen. Could become a category 2, but it is fighting some wind shear, as is indicated here. There's some wind shear and some dry air. And based on the lopsidedness of the system, I would say most of the shear is going this way. So there is a little bit of shear, not much, but I believe what's really hurting the system isn't so much the shear, but it's dry air. Because there is definitely outflow. There is outflow with the system. However, there is dry air being entrenched into Fausto, which is hurting its development a little bit. Now we're going to go back to Bertha. We're going to look at long wave. Actually, no, I wanted to look at, visible shortwave. That's what I was looking for. You can see the exposed low-level center right here. There is the low-level center. There is definitely displacement. And the convection is moving further south because of the strong northerly shear. You can see the strong north winds right over here. You can see there is wind shear, which is really hurting the system. Normally, wind shear you wouldn't want outflow. You would want good ventilation. The system is being completely choked off by all this high altitude winds coming in from the north and northeast. The shear is expected to weaken a little bit, but you can see the center of circulation almost directly east of Louisiana, south of the Florida Alabama border. Some of the models have it going a little bit south, possibly because of the trying to coordinate with the circulation, and also because there's going to be high pressure aloft, which will force the system to go a little south and west. However, the HRRR has this low-level center going due west and west-northwest, going over New Orleans, over Lake Pontchartrain, or over Lake Maurepas, and then almost going into Mississippi. However, the NAM 3KM has this going south and becoming a strong tropical storm before coming into Texas. There is also a possibility, very unlikely, due to all the shear right now, that when the system moves over the very warm waters here, plus 30 degrees Celsius, even 31 Celsius, that there could be a big blow-up of convection right over the center once the shear weakens. It is unlikely, but it is possible. I will look at sea surface temperatures for the Gulf. I know they're going to call it the Gulf of America. I will not call it the Gulf of America. I will call it the Gulf of Mexico. Because that's how it's always been named, and that's how I will continue to name it. It's not about political stuff. In fact, I hate how everything is becoming so politicized. Oh, Gulf of America, Gulf of Mexico, Gulf of America, Gulf of Mexico. No, it's going to be the Gulf of Mexico. All right, so right now it's over water temperatures that are just about 30 degrees Celsius, about 86. But there are some very warmer waters here, up closer to 31. but it's not much of a difference. It's like, oh yeah, 86.4, 86.7. It's pretty uniform temps. It's pretty uniform. There's a little sliver of 31 degrees Celsius here because of the heat waves. And then you have that cold current that runs down Mexico and upwelling here. But it's 28 Celsius. That's still conducive for tropical development. So what's really hurting the system is not the water temperatures. The water temperatures are very conducive. It is the dry air and the wind shear. And from what I've been hearing, it's expected to weaken. I thought I muted this thing. Okay, I might have to mute this thing. Alright, there we go. So yes. Definitely trying to hold its act together, but it's having a hard time. So let's look at radar. There is your circulation. I believe that's your mid-level circulation. Your surface circulation is further north, about here. This is your mid-level circulation. Your surface circulation is up here. So there's a huge difference between the low level and the mid-level. And yes, the surface circulation will try to migrate south. Or that the surface circulation here will weaken and a new low will try to form here. You can see the northwest movement here, the southeast movement here. So you do have a upper level, or not upper, mid-level circulation here, mid-level. That is your mid-level circulation. Your surface low is here. Right now, it is still there. You still have a surface low somewhere in this region. And how do I know this? So let's go back to visible. They're saying the models, or the radar is saying that the surface circulation, or that swirl, is in this area. So let's look at radar scope again. There's your mid-level circulation, southeast of, I'm trying to see where that is. So it is southeast of Plaquemine Parish. So that's Plaquemine Parish right here. So it's southeast of Plaquemine Parish, southeast of the mouth of the Mississippi River. Not east, or even east-southeast, but southeast. So when we go to a radar scope, or satellite, jeez, I'm so tired. When I go to satellite, southeast, we'll pinpoint that little surface, the mid-level circulation, somewhere around here. But you can see the low-level swirl is here. There is your low-level swirl here, but your mid-level circulation is here. And this will likely weaken, and a new circulation will form down here. Not saying that will happen, but it could. Tropical systems that are fighting shear normally do this, where the surface circulation gets ripped away from the circulation, and then once a mid-level circulation forms at a different place, once the first surface low weakens, a second circulation will make its way down to the ground. And the cycle repeats as the system tries to organize itself due to fighting the dry air and shear. But that will weaken. Even though you will still have wind shear, as the system is moving west and the winds are also moving east to west, that will kind of weaken the shear, because you will have the same direction of upper level winds and the movement of the system, which will mean you'll have less shear. You'll still have, it's likely that the upper level winds might still be stronger than this system is moving moving west, but you won't have directional shear. You'll just have speed shear, not directional. Right now you're having speed and directional shear. You need having strong winds, and they are moving almost perpendicular to the motion of the system, which is slowly moving west. But that will weaken, but it will still be fighting some dry air. But once the shear weakens, the system will be able to become more organized and stronger. It will not become a hurricane. I'm just going to point that out. You will not be having Hurricane Bertha. I'm sorry, but no. I mean, it's not 100% no, but as of now, I am just going to say no. Yes, the NAM 3KM is overperforming like always, but the NAM 3KM is being the NAM 3KM. It always overestimates. Yeah, look at that. Yeah, that's not going to happen. I'm sorry. The 18Z was showing a Category 1, like a strong tropical storm. This is showing a Category 2, maybe even a 3. I would say Category 2 coming into Texas. Yeah. Yeah, a Cat 2. 963. It was showing the same thing yesterday. It was showing a hurricane yesterday coming towards Louisiana. So just take this with a grain of salt. You can't really believe everything you see with a computer model, especially with one that overdoes stuff. It kind of handled Hurricane Michael well back in 2018, and I based the NAM 3KM back in 2018 saying that Hurricane Michael will be a 5 when it strikes the Panhandle, even though all the other models, not these models, but the hurricane models were showing a weak system. I was explaining why the models were wrong. I was showing the water temperatures, the lack of shear, the lack of dry air, and I said it has the potential to rapidly intensify. And that's what it did. However, it wasn't just looking at the models. I was looking at the atmospheric conditions, the oceanic temperatures. You can't always trust the models. Sometimes you have to trust, what the science dictates, what your knowledge teaches you. I'm self-taught. I didn't learn this in school like most meteorologists do. What the hell is that? Oh. I hate when that happens. Ugh. I hate when this happens in the middle of a live stream. Yeah, I just got interrupted by Java. Anyway. But yes. Also, Texas, according to the NAM, is going to have a huge heat wave, which is kind of normal for Texas, but yeah, it's pretty bad. And they're going from flooding to extreme heat. Yeah. Oh, look at those storms. That'll probably be a relief, but it'll also make the humidity go sky high. Ooh, with that heat and those storms, yeah, that could actually become an MCS. Yeah, potential for damaging winds and hail with that. Even though I'm looking at temperatures, you can tell that's a very intense line of storms. Let's look at precip, simulating reflectivity. It is a 12Z run, so I'll also take that with a grain of salt. But I'm just interpreting what the model's forecast. Yeah, MCS. Sorry, not MCV, MCS. All right, let's look at 0. Right, go back to the current. Look, this is not going to happen. A very unlikely. Like, look what it's showing. It's showing just a sudden move south, and then decide, I want to go for Texas. Yeah. Probably not. So, yeah, take this with a grain of salt. But I would watch this if I were between Houston and Corpus Christi. Just putting that out there. It's very unlikely. And what is this model going to show? Yes. It's going to show it moving into Louisiana and then trying to go into Mississippi. Yeah, look at that. Actually, I think this is more believable. I mean, yes, the NAM is trying to say it's going to go southwest, it's going to get dragged south. However, there is definitely disagreement. I mean, all the other models are saying it's going to go west. Look, this model too saying it's going to go inland. I personally think the low level circulation is going to go northwest. I personally believe that this is going to happen. Does not matter what the other models are saying, like the NAM3KM, unless that mid-level circulation drags its way back to the surface, and that surface circulation to the north gets dissipated. This will happen. It could be you could have two circulations. You could have two surface lows at the same time. It's not inconceivable that could happen. It's happened before. Tropical systems fighting dry air. That you could have two surface lows simultaneously for the same system. That will not mean you're going to have another name. It's going to be the same system, so the same name. It will still be Bertha. You're not going to have another name. It's basically a handoff, like how when you're having a system moving through the Appalachians, you will have a secondary low forming along the coast. Same system, it's just a transfer of energy from one part to another. So again, let's look at radar scope. See, there's lightning inside the mid-level circulation. This means that there is a lot of convection in here. There's a good deal of convection in this mid-level swirl. See right here, there is a southeast swirl. There's a southeast movement here. If this circulation, the surface circulation, was here, and everything was rotating around that, this would actually be going west, not southeast. Meaning, this circulation is taking over. This is taking over from here. So really, this doesn't really matter. It matters now, but in a few hours, you will see this is going to end up further south. You see how it's getting weaker, it's becoming more open. The surface low is weakening. This surface low is weakening, and this circulation here is trying to make its way down to the surface. That is what's happening right now. Okay, so far, got 17 total views. All right. Again, this is infrared. Why is the convection seemingly moving this way? That's because of the thunderstorms rotating around the mid-level circulation here. Yeah, this is falling apart. You're gonna have a new swirl further south, and it will still try to move west. It could make a few jogs north, but it's most likely going to be moving west to try to center itself under the strongest storms. The center of low pressure wants to be around where all the rising air is, so it keeps on forming itself. The mid-level circulation is constantly trying to form itself. It almost looks like it could be trying to even go further south. But on the infrared, you can clearly see the wind, the upper level winds. You see how this is moving like that? For a healthy system, you would want, this is the motions you want, not this. You definitely do not want this right now. So it's completely shearing the northeast side of the system. I mean, yeah, the wind shear is a forecast a weekend, but it's very strong right now. Let's look at satellite imagery for the entire country, not just the Gulf of Mexico, but the entire region. Let's look at, yeah, this is a little better. Yeah, this is too, yeah, it doesn't give you long loop. So let's look at the Atlantic wide. So part of the reason for the shear is all this convective activity to your north. So you have a high pressure system here. You have a high pressure system over the southeast. Pretty strong high. So we had some thunderstorms. We even had a supercell go through New York City. Even though it doesn't look like much on infrared for New York, we actually had a supercell go through Manhattan, and I was there. I'm going to upload the video later. But yes, we had a supercell. I had a supercell go through. If I were to look at this, I would think, yeah, that's a tropical depression. It looks interesting, but it definitely doesn't look threatening. That looks very impressive over Tennessee. That is a very impressive band of storms. Definitely overshooting tops there. Those are some very cool cloud tops. -80. Yeah, those are hot towers there. So let's go back to satellite imagery and let's look at... Let's see if I can find any floaters. In Northwest Atlantic. Can't really find anything for those storms. This is the best, I guess. So, all right. Oh yeah, there are hot towers there. Almost looks like, huh. Oh yeah, there's an overshooting top. You see right here that it almost looks like a little hole right there? That's evidence of an overshooting top. That little hole that you're seeing, those are warmer cloud tops. Cold, and a little bit of warm there. That means it's over the tropopause. Yeah, it means it's went into the stratosphere, which is actually inverted, meaning it gets warmer as you go up. Yeah, that's overshooting. And here's a crazy thing. There's no severe thunderstorm warnings, just heavy rain. Yeah, a lot of rain in those storms. A lot of lightning, too. Special weather statements. Yeah, the highest cloud tops is over KPVE, which is Beach River Regional Airport. Very impressive cloud tops there. Which I believe, oh yeah, wow, over 40,000. There's, yeah, yellows over 40,000. That normally would mean hail. What? Still orange? I just went up to tilt 3. Oh yeah, those are over 50,000. Might have to go to tilt 4. Okay, 51,000. All right, let me do tilt 4 now. Yeah, because that's getting really high now. Yep, over 60,000 feet. Over Parsons, there is a cloud. Okay, I'm gonna have to go to radar scope to show you guys. I'm talking about this right here. I'm gonna zoom in. Hopefully. All right. See right there, that lighter orange. Right there. That's like those colors here. And you see there's 2 rings of very cold clouds. Here and here. That almost looks like a volcanic eruption. That's almost looks like a grander scale of what happened with Honga Tonga Honga Ha'apai. Why is this happening? Well, that's because the clouds are overshooting. There's your hot tower. Very cold. But then, right here, a little smidge of warmer temps. That's because it's rising into the into the stratosphere, which is warming the cloud tops. That's what's happening here. These areas are below the tropopause, hence they're colder. And why is this peak the coldest? Is because it's probably still cold, even though the parcel is still rising. There is a area of smidge of colder cloud tops as it punctured the tropopause. Yeah. We just had a cloud top over Parsons, over 60,000 feet, with DBZs of up to 31, despite being over 60,000 feet. And not severe. It's just literally all water. And the radar site I'm using for Tennessee, get this, is in Jackson, Mississippi. Tilt 4. I'm going to do that right now. I'm going to go to Tilt 4, KDGX. That's the cluster I'm talking about. Almost looks like a hook, right? Yeah, this is almost 40,000 feet. Also, over 40,000 feet. That's like 45,000. Yeah. See, 46,000 feet. Yeah, very tropical. That's because of a lot of buoyancy there. Yeah. Now we're going to go to Tilt 4. Right there. Yeah, you see this, right? That's like 65, 66,000 feet. You see how it gets clipped off? Yeah. That's just because of how high it is. And I will be using the cloud top estimator too. Come on. Yeah, it's kind of freezing on me a little bit. All right, let's go here. Yeah, 65,000 feet. Yeah, 64.3 thousand feet. And then look at that peak of intensity right there. Yeah, 60,000 feet and still that. Very impressive. Now I'm going to go to a local radar, which is Nashville. And the cells, they don't look like hailers. They just look like ordinary thunderstorms. They are not surface based, these are elevated storms. Or at least are higher based. So now I'm going to be going to enhanced echo tops. There we go. Yep, right there. 60. Yeah, definitely underestimated those cloud tops. Might try to go to a different site. Whoop. Yeah, 62. Was that a 63? Yeah, I think there was a little 63 in there. Yeah, 63,000 feet. Very, very high cloud top. 63, 63. Oh, 64,000 feet. So I wasn't wrong to estimate those crazy high cloud tops. Not the highest I've seen. You want to know the highest I've seen? June 22nd, 2023 in the Chicagoland area. Yeah. I'm going to go back to the tropics, but I just want to show you. Highest I've seen was June 22nd. June 22nd, 2023. I think like 7 p.m. Like it was like in the evening time. Select. Or was it 2022? think I could. I'm just looking for the server where I wrote. Um, there we go. Found it. General. June 13th, 2022. Okay. June 13th, 2022. I just got my dates wrong. June 13th, 2022, around 6:30 p.m. Let me change it to 6:30. All right. Select. 13th. There we go. So it's a little later. Yeah, that's the cluster I'm talking about. See how it's just forming? Now we're going to be going at reflectivity. Yeah, this is kind of early. What time did I say that? I think it was at 8 p.m. Okay. It was an hour later. Select. Oh, yeah. Yeah. It was a supercell. Yeah, it was a... It was basically a supercell with those insane cloud tops. Yikes, that was a supercell. Let me see the warning. Yeah, hail. I don't think it produced a tornado. Yeah, radar indicated rotation in 2-inch hail. So it was a supercell, and then it kind of, I believe, gusted out. It became like a... Let's go 8:15. Oh, yeah, it hit Chicago. It definitely hit Chicago. You don't look like Chicago's just going to get... Wow. And then it got hail, too. So this was a supercell. This wasn't a... just like a line of storms like I originally thought. I think that was a different system then. Yeah, that's a supercell going through Chicago. That's a freaking supercell, guys. Yeah, I think that might have been a different system. And I did mention 70,000 foot tops in Chicago. It might have been that storm. Let me look at different radar sites because there was like a Catlin X. Yeah, that definitely might have been the storm. Now by the looks of it, yeah. Wow, look at that hail core. That is insanity. Yeah, 1.75 inch hail. Dime size. Okay. All right. Yeah, that's a supercell. That's not just like a hail core. Okay. What were the tops that day in Chicago? I think I ended up going to. That's weird. I have to go to KLC, St. Louis. Let's see, St. Louis. Let's go to tilt 3. Get too far. Yep. You see how You see how it's been clipped off? Yep, that might definitely be the cell. That's why I thought cloud tops were over 70. Right there, see? Yeah. And yeah, and the strongest part of the cell is over there. Yeah, that's why I thought 70,000. All right. So Chicago got the core, but the strongest wind stayed to the southeast. There's your rotation here. Now we're going to be looking at those enhanced echo tops. Yeah, see, oh, 50,000. Oh, please. Yeah. Those were not 50,000 foot tops. Yikes. Now look at that. Look at that. 65,000 foot tops. Yikes. 69,000 feet topped. And this is live too. At the time, I don't think I was live. I think that's the highest it can go. Yeah, look at that. Oh, 70,000 feet. No, I don't think that's an overestimate. Based on what I saw from St. Louis, yeah, I think that's accurate. That must have been an insane supercell. Definitely stratospheric injection of water vapor. That is insane. 64, 68,000 feet. Look at this whole area of almost 70,000 foot tops. 7:50 p.m., right? Insanity. Just insanity. Yeah, that was the storm. Yeah. Oh my goodness. Only reason I didn't think it was like that intense was because wait, I'm like, why isn't the hail that big? Yeah, insane. All right, now we're gonna be going back to tropics. Tropical storm Bertha. Come on. All right. Oh yeah, that's right. I'm gonna have to go back to the present. Yeah, because at the time, KHTC was not active. KLIX was. There's your surface low trying to form. I think we might be getting a new surface low. Yeah. Yeah, we got a new surface low. That's old. Wow.
On va essayer de trouver une source chaude pour allumer la guérande. Ça y est, j'ai trouvé. Calme rapide. Travail, tout devrait bien se passer.
Yeah, that's a surface low trying to form. Alright, the internet's about to be shut off. I just hear somebody running downstairs to shut off my Wi-Fi. Meaning, in less than a minute, this is going to go down to 0, and I'm going to... You know what? Just to be safe, I'm going to end the live stream now. Yep, I think it just went down to 0. I'm going to give it 10 seconds. Yeah, my family is absolutely toxic. I could be wrong, but normally when I hear people going downstairs, it's normally to turn off the Wi-Fi when it gets usually around like 12:30. But sometimes they do it as early as 11:50. It's not because they want to sleep. It's I don't talk that loud. Plus, I have a door that I close. It's because they don't want me on the computer. That's simply it. Oh, never mind. They're going back upstairs. Meaning they just wanted to get something. Okay. But if my stream ever just freezes, you'll know why. I mean, I could also turn on my hotspot, but anyway, just bear with me for a second. I'm gonna reset this. Let's minimize. Reset. There we go. Yeah, that was an overshooting top. Not to the insanity that Chicago had that day, June 13th, 2022. That was insanity. That was June sanity insane. I was like insane. Because there's a big cluster of thunderstorms just to my south. I mean, New York City already had its thunderstorms. I actually was at a site of a wall cloud. Wall cloud hook echo passed right over me. I was in Midtown. The hook passed right over me. Not the rotating part of the hook, but the part that wraps around. The part that I would say produces a tornado, would have produced a tornado, was about a mile to my southeast. I was pretty close. It was about 4 p.m. when this happened. I'm just gonna go back to KDI. Actually, I was using JFK. Actually, no, I was using KDOX. When I spotted the storm, it was like 3:30 p.m. when I first spotted the storm. Yeah. Actually, it was like 3:45 when I first spotted it. And here's the thing, it didn't look that impressive, to be honest with you. Yeah, see? That was the cell. That was the cell that produced a hook. But, go to KDIX. Again, doesn't look impressive. Go to KDOX. Looks a little more impressive. Not that cell, it's this one right here. Let's go to 350, right? It's close to about 4 p.m. when this happened. Select. Yeah, there it is. 3:50 p.m., right? Now 3:46. That wasn't, see, it just looks like a light shower, right? Doesn't look like much. This didn't do much. And this is the cell that produced the tornado right here. I mean, yeah, it had a pretty good hook with it. And there was a video that showed what looked like a wall cloud or a wedge. But the damage wasn't too bad. It was, I would say, from what I saw on TV, it was EF0. But I'm not the National Weather Service, so I can't make that determination. All right. And this is what I got really excited, because at the same time I was looking at Binghamton, and like about 5 minutes later, about like 3:54ish, this is what I saw on radar. 3:54 p.m. Why I got excited? I was like, ooh, this is good. Yeah. Actually, no, it was like 3:50 actually. Yeah. Tiny little hail core, right? Yet, what did it look like on radar? Light shower. Yeah, that's what it looked like at 3:50. When Binghamton was showing this huge hail core, that's what it looked like. And look what's approaching! The gust front from these cells. Yeah, and that's why it probably rotated. And I was really excited. I was like, because I was on the edge of this cell, so I was like right here. I was thinking maybe I should go further south, or I should stay here, because I missed the other train. I missed. I missed the 6th train, and I was mulling whether I should wait 3 more minutes or should I just go outside. But when I saw this at 3:54, it's like 3:55. When I saw this, I'm like, yeah, because I was here. You see how fast it's going? 3:48, right? 5 minutes. Look how fast it goes. 3:45. In literally 8 minutes. Look how much ground they covered. I was worried if I took that train just a couple minutes, I would have missed the whole system. It would have been over by the time I got up. Of course, that's elevated. At surface, it's moving at a different speed, probably. But in the end, it didn't really matter, I guess, because I don't think any hell reached the surface. KDOX, that's what it looked like, and I was about here. Again, doesn't look like much, just looks like a heavy shower. And at the surface around this time, because keep in mind, this is 3:53 p.m. Just looks like a moderate shower, right? Light moderate shower. But at aloft, it looked more impressive. See, that's 3:54. Let's go to 3:56, right? Select. Boom! Yeah, TGFK, it was just starting to rain. I was outside, there was already thunder and lightning. Keep in mind. Okay, it normally means the internet was turned off. Look how quickly this moved. In only 4 minutes. See? In only a few minutes, boom, look how much ground it covered. Yeah, this is the part that would have had to hail, because look, you see the gust front, right? You see it coming in, and then this is why I was thinking about going south, because I wanted to catch the core. Let's go to 4 p.m. It was about 4 p.m. when the heaviest of the rain started. Yeah, at that time they issued a special weather statement, which was for, I believe, for wind and maybe some small hail. Yeah, pea-sized hail. All right, let's look at KOKX. Yeah, that's what it looked like. Yeah, it was pouring, and at that time I was like right here. Cause at 4:10, just 10 minutes later, yeah, it was over. And I believe I was right around here. And you see, kind of looks like a hook. And you see the gust front. You see, yeah, this is where you would have the inflow right here. Yeah, your gust front here. Yeah, this actually was rotating. This actually became a supercell. Doesn't look like it's having a rotation, but it was a hook. It was, I mean, it was a supercell. Never became tornado warned, but yeah, that was a hook. I mean, it had a hook on it. Yeah, look right here. You can actually see the hook. Not this. That's just a random shower. But you can actually see what looks like a hook right here. Not a very impressive one, but you do see that hook. And I was showing you that trailing gust front ending right about here. So yeah, that was indeed a hook. So now let's go back to the tropics. Let's go back to aircraft reconnaissance. Mission 10. Alrighty. Yeah, the center of circulation, the surface circulation is still here. But your mid-level circulation is down here. You see how it's only 997 millibars? Yeah, it's gonna relocate south. And it's been doing those jumpy around. It's been jumping around. In fact, let's go to Bertha. See, they're kind of even showing might even move a little south. Yeah, so the National Hurricane Center is trying to be like, yeah, it might move south. Yeah, see how it just moved northwest? And right now, how it's kind of moving west? See, moving east? Yeah, I believe this system will relocate further southeast. All right. I'm gonna look at volcanoes as well. I'm gonna look at Copernicus browser. No, I already have that open. There we go. Anonymously. This is your Iwo Jima map. Yeah, July 22nd. Alright. Alright, this is what Iwo Jima look like. We're going to be going to the present. Well, not the present. Let's go to the, 19th is off limits. Huh, it's weird. Huh. Why is the 19th not on? Must be some sort of glitch with the whole thing. Maybe I just gotta reset it. Could be a glitch. It could be that it's restricted or something. Still working. There we go. That's probably it. I'm live. I'm live. Нет, Stephanie. I cleaned it. Alright. Alright, there we go. I think I just had to reset it. There we go. There we go. I knew it. It wasn't that it was restricted, it just wasn't working. Huh. That's weird. What is that? Why is there this lone cloud over Iwo Jima? Is there another eruption? That is very sus. Okay, that is sus. It's almost seemingly, almost seemingly originating from, what? Where's that? Suribachiyama. Yeah, that is very, very suspicious. Um, yeah, this could be an eruption. This might be an eruption, guys. Could also just be a cloud that's forming over the, or just passing over the island. But this could be an eruption. All right, I'm gonna have to post this. Have you guys checked Iwo Jima for July 19th? Can't confirm if it's an eruption or just a big cloud right over the island. But it looks sus. um, seeming okay. It definitely looks more like a cloud. It could be some sort of shower over the island. Uh, it could be meteorological too. Mm, It's like, let me zoom out to see if it's anywhere else. No, it's just the island. It is literally just the island. You know what? I'm gonna be I'm gonna be using I know exactly what to look at. Zoom. I'm gonna be checking Zoom. Not Zoom communication, Zoom satellite. Different Zoom, Zoom Earth. It could be the same company or it could just be unrelated. Alright, so we're gonna look at June 19th. No, I don't want to look at that. Zoom was only a few days ago. Alright, so we're going to try to figure out what time this was, because that was very suspicious. That was July 19th, right around Iwo Jima. Alright. Iwo Jima would be right about here. No, that's the Northern Mariana Islands. There we go, Iwo Jima. Okay, that's North Iwo Jima, I believe. Yeah, okay. Where is the island? Am I too far north, too far south? Am I on the wrong chain as well? Okay, yes, there we go. Yeah, that's the volcanic part. There we go. Um, yeah, I think we might have an eruption. Yeah, guys, I think we have an eruption at Iwo Jima. Oh, crap. Just check the Zoom satellite for June 19th. There is a plume. did we miss this? How did we miss this? How did we miss this? Ugh. Oh, goodness. It could be meteorological, too. Alright. Yeah, it's definitely volcanic. I think it's back. I was right to assume there was something suspicious going on around the island. Alright, I can't confirm if this is an eruption, but it definitely looks suspicious. Okay, right now, okay, nothing right here. June 17th, all quiet. Nothing going on. Alright. All quiet. And wait, that could be meteorological. Yeah, see, there's thunderstorms. Can't really tell if there's anything going on. Alright. That's when it starts. July 17th. Yep, July 17th. 17th of July. Okay, I'm gonna have to go back. At first, when I saw that on Zoom, I'm like, that's definitely sus. I wanted to rule out meteorological stuff, so I checked Zoom during a live stream, and sure enough, it's definitely likely volcanic. But it can't be ruled out. Yeah. Yep. All right. I am messaging Geology Hub now. All right. Yeah, this is. Oh God. What the heck? Alrighty. Where is Geology Hub? Come on. There we go. We have a situation at Iwo Jima. Saw this when looking at Iwo Jima on the 19th. just a few hours ago. Just now. Period. It didn't update till today. I checked Zoom satellite, and there's definitely a plume coming from the island. We may be having another eruption. And by the looks of it, it could be coming from Surabachiyama. Or just to its north. That's what I thought too. I also thought it was a cumulus cloud. But then I thought that looks kind of sus, so I checked Zoom satellite, and sure enough, there is a plume originating from the island. The plume started on the 17th, and it's still continuing. Yep. Actually, the plume dissipated earlier today. Gee, there was a plume on the 17th. Here's why I think it's a plume. Yeah, that's weather related. Weather related, weather related, weather related. Okay. There we go. Okay, that's probably still weather related. Oh, come on, come on. Yeah, that could also be weather related. Let me check. There we go. There's your plume. There's your plume. Actually, he might be right. That could just be plume. Yeah. Right. Oh yeah, I could just screen record on my phone. All right, I'm gonna go to Zoom satellite. All right. Yeah, we might be having another eruption. Can't confirm, but they could be right. That this could just be a cloud over the island. I mean, yeah, it looked like a cumulus cloud, but it also looked kind of suspicious. Yeah, those are clouds. Clouds. There we go. There's Iwo Jima. There's Iwo Jima. There's that little tropical system. Or upper level. Yeah, that's an upper level system. Yeah, that's just weather. Right. Wow, the upper level low is right over Iwo Jima on the 16th. And on the 17th. Okay. I'm gonna turn on the microphone. Try to make it under 30 seconds. The cloud in question was on the 19th. So for now, this is weather related. Let's go to the 18th. This is where the plume starts originating, right here. You see how there's just this cloud that's sitting right over the island? It's kind of like what happened when the eruption started on the west coast. Yeah, I think we might have had another eruptive activity, another eruptive episode at Iwo Jima. Yeah, see? Yeah, we had another eruptive event. There was a plume originating from the island for almost an entire day. Alright. Alright. So I'm gonna have to restart the video. So on the 17th, things looked a little suspicious in the afternoon. Like right here. See, there's this cloud that's just sitting over the island on the 18th. And then it continues into the 19th. Yeah, I think we did have an eruptive event. Some sort of phreatic activity, could just be steam venting, either a significant increase in fumarolic activity, or possibly some eruptive activity. Yeah. Yeah, and then on the, yeah, see, and then it technically ends. See, right now, not really anything's still going on. It's still ongoing. Yeah, yeah, it's still ongoing on the 20th, to some extent. And then this storm system comes over, kind of messes things up. Okay, this pops up here, so I don't think that's related to island activity. Alright. If it is even related to island activity, it's entirely possible that could have just been weather at Iwo Jima, but it looked more like it was related to volcanic activity. Okay. And there is a small plume. Yeah, on the 20th. Okay, too much clouds. Can't really determine. Okay, 7 p.m. Too much clouds, too much clouds, too much clouds, too much clouds. Yep, it's ongoing. We have some sort of eruptive or yeah, there is some sort of event ongoing at Iwo Jima. Iwo Jima is too low for orographic uplift. Yeah, I definitely think something is going on at the island. I'm gonna check Twitter. I think something is happening at Iwo Jima right now. I'm gonna go to X, even though I hate X personally. Oh, come on. Give me a second.